Today, we'll be starting our new unit, Unit 6, which is all about triangles. The first lesson will be about types of triangles. We'll classify triangles by two different ways. One is by the sides, and the other is by the angles. Remember that the sides are these outer segments that connect the vertices together. There are three ways to classify by sides. One is equilateral, where all three sides are the same. Isosceles triangles that have two equal sides, and scalene triangles that have no equal sides. The other way to classify is by angles. Remember, the angles of a triangle are formed by the two sides. It would be the measure of like this space right here where the cursor is. The way that you would identify or classify your triangles by angles, one is acute, where all three angles are less than 90 degrees. The other is right triangle, where there is one 90-degree angle. And the last one is obtuse, where there is one angle that is greater than 90 degrees. Today, we're going to focus on classifying by sides. In the equilateral triangle, all three sides must have exactly the same measure. They must be shown by either giving the actual lengths of the sides or by the congruent tick marks. In this example down here, we have 20 meters, 20 meters, and 20 meters. Because all three are the exact same measure, then we know that this is an equilateral triangle. In the example on the right, we don't have actual measures, but we do have these green tick marks. And because they all have exactly one tick mark, we know that those are all the same measure, and therefore it would be equilateral. In the isosceles triangle, exactly two sides have the same measure. That must be shown either by the actual lengths or by two congruent tick marks. In this diagram, it's marked with each. We have a 5 centimeters and in 5 centimeters. This one down here is 6, so they're not all three the same, but these two are. And we can see also we have this one red tick mark and one red tick mark. And then down here, this one has two red tick marks, so it's not the same. Since these two are the same, we're looking at an isosceles triangle. The last one is scalene. And in a scalene triangle, none of the sides are the same measure. Again, it can be showed with actual lengths or by different tick marks. In this one, we have 9, 13, and 14. Since all of those are different lengths, we can see that that is a scalene triangle. This one uses tick marks. We have one tick mark, two tick marks, and three tick marks. Since none of the ticks are the same, we know that's a scalene triangle. There is some more information about those particular angle measures that are found within the triangles, two of them anyway, equilateral and isosceles. In an isosceles triangle, because all three sides have the same measure, that also ends up resulting in all three angles being exactly the same measure. So we would have 60 degrees, 60 degrees, and 60 degrees in every corner of an equilateral triangle. In an isosceles triangle, not only do the two sides have the same measure, but there are also two angles with the same measure. It happens to be the angles that are called base angles. They're opposite the congruent sides. So if I look at side B right here, the angle that does not touch it, so this one right here touches it, and this one right here touches it. The one that is opposite, so now I've got my cursor on that one, that is opposite. It's its base angle. Looking at this side over here, the top angle touches it, the bottom right touches it. Its opposite would be this one on the bottom left. It's its base angle. So these two base angles are the two that are congruent. The way I can usually remember that is where the two sides that are the same length, where they touch each other, where they meet this one up here, that's not a base angle. It's the other two. So we should be able to use that information then to help us find missing values or a value of x. So if I'm looking at this diagram, I can see I have 1, 2, 3 tick marks on there. So this is an equilateral triangle. All three sides will be the same. Now I don't have a measure down here on FH, but that's okay. I have FG measuring 3x minus 10 and GH measuring 5x minus 8. Since they have the same tick marks, those two measures have to be the same. So FG will have to be equal to GH. And I've written that over here in bold. So then I've substituted in their measures. So FG measures 3x minus 10, so I put that on the left side. And then GH measures 5x minus 8. I've put that here on the right side. Now we have the equation, and we solve that. There are like terms. They're on different sides of the equal sign, so we need to do an inverse to one of them. I picked the 3x. So to do its opposite, we would subtract 3x. What you do to one side, you have to do to the other. 3x minus 3x is 0. That part's gone away. So now we simply have the negative 10 to bring down, the equal sign to bring down. 5x minus 3x is 2x, and bring down the minus 8. Remember, it's our goal to get x alone, so we need to get rid of the minus 8 that's on that side. So we'll do its opposite and add 8. What we do to one side, we do to the other. Negative 8 and 8 will cancel out, so there won't be that piece there anymore. Negative 10 plus 8 is negative 2. Bring down the equal sign, bring down the 2x. Remember, this has gone away. That equals 0. To get x alone, we still need to get rid of the 2 that's in front of it, so we would divide by 2. What we do to one side, we do to the other. Negative 2 divided by 2 is negative 1. Bring down the equal sign. 2 divided by 2 is 1x, so x has a value of negative 1. Now, we could plug that in up here and see what those lengths would happen to be, but we don't have to. And then we have a question regarding this triangle, and you'll see there's x's on all 3 of the side lengths, but I can't use all 3 of them because this is not an equilateral triangle. This is an isosceles triangle. So only 2 measures will be the same. And we have a tick mark here on CA and a tick mark here on AB. So those 2 are the same. So CA or AC, whichever way you want to name it, has to be the same length as AB or BA. Again, doesn't matter the order you list those in. So I've written here that AC has to be equal to AB. Then I've taken AC's length, which is 2x minus 1, replaced it there on the left side. And then I took the length of AB over here on the right, x plus 7, and replaced it for AB on the right. And then we have our equation, and we solve it. We have like terms. They're on different sides of the equal sign, so we pick one and do its opposite. I picked this x right here on the right side, so I subtract x. What I do to one side, I do to the other. 2x minus x is 1x. Bring down the negative 1, bring down the equal sign. X minus x is 0. That's gone. So we bring down only the positive 7. X is already almost alone. All we have to get rid of is the minus 1. So to do that, we would add 1. What we do to one side, we do to the other. We bring down the x. Negative 1 plus 1 is 0. That went away. Bring down the equal sign, and 7 plus 1 is 8, so x would have a value of 8. Now, if it had asked us, we could also find then the length of this side because we could plug the 8 in, but the question didn't go as far as asking us to find the actual lengths. One more question. So this one's a little bit more complicated, has a few more steps than the last 2 did. Asked us simply to find the value of x. All this writing over here is all my thought. So the question would just say, find the value of x, and you'd have a diagram like this of triangle RST. So we have to look at the drawing and see what we notice. So first of all, I notice that we have a 6 here, a 6 here, and a 4. So it's not equilateral. They're not all 6, but I do have 2 matching lengths, the 6 and the 6. So that means that SR and RT are the same, meaning this is an isosceles triangle. So now I'm going to use my isosceles triangle information. 6 and 6 have to be the same, and so do their base angles. So the angle that's opposite this 6 on the right would be the bottom left, this one that's marked as an X. Then the angle that's opposite this 6 would be this one over here at angle T. That should be the same. They have to be congruent. So if angle S is marked with an X, then angle T should also be the measure of x. So these 2 would both have x's in them. Then we have a 32 up there at angle R. Remember I mentioned to you earlier where the 2 lengths that are the same come together. That is not the base angle. It's the one that's different. So these measures down here should not be 32s. We know they should be something else. Now we need to remember something that you learned back in middle school. And that is that the angles of a triangle all add up to 180 degrees. So we're going to put those 2 ideas together. We're going to look at angle S and angle T being the same, and the fact that triangles add up to 180 degrees. All right, so since S was marked with an X, T would also be marked with an X. We would symbolize it this way. The measure of angle S equals x. So the measure of angle T equals x. So since they're all going to add up to 180 degrees, 32 from angle R, x from angle S, and x from angle T, all 3 of those right here, have to add up to equal 180. Now we're going to solve. So I have like terms. They're on the same side of the equal sign, so I just collect them. X plus x is 2x. To get x alone, I need to get rid of that 32. So we'll subtract 32. What we do to one side, we do to the other. So bring down the 2x, bring down the equal sign, do your subtraction, and we get 148. Then we have to get x alone by dividing by 2 on both sides. 2 divided by 2 is 1x, and 148 divided by 2 is 74.